This is Algebra 2, Chapter 8, Section 5, in which we will study variation functions. When we talk about a variation function, there's several kinds, and we're going to look at each one. The first one is a direct variation. All we're talking about here is a relationship between quantities, between variables, that can be written in the form y equals k times x. K is called the constant of variation. Okay. The secret to direct variation, folks, is that if x gets bigger, y gets bigger at the same rate. Okay. If x goes up, y goes up. If x goes down, y goes down. Okay. The secret to these problems is finding k using one set of information, and then after you have that k, use that k to find the new information. So they tell me here r varies directly as t. R equals negative 20 when t equals 4. Our job is to find r when t equals negative 6. Okay. I see several things that are important. R varies directly as t. That tips me off to my equation. If r varies directly as t, then my equation is r equals k times t. This is varying against this. The one that's varying first is the one that goes independent over here. Now, I see a set of values that goes together. R is equal to negative 20 when t is equal to 4. Those two things happen at the same time. So I'm going to use those two in my equation and solve it to find k. Now I have a value for k, so I can plug that into my equation, r equals k times t, and I have a new value of t. So now I can plug in, I know k is negative 5, I know t is negative 6, I can find r. Okay. If they asked you for the equation of variation, it would be just plugging the k back in, so you would have r equals negative 5t. Direct variation's not that bad. There's a special variation of direct variation, and that's called joint variation. All right, typically with, why is that like that? Space over there, we go. Typically with direct variation, what you're talking about is just two variables, y and x, for example. In joint variation, you have typically three variables, such as they say r varies jointly as v and t. That statement tips me off to my equation. We're interested in the product of v and t. Our job is still first to find k. Our equation is r equals k times vt. V times t over here. Okay. Now I have some information that goes together. R equals 70 when v is equal to 10 and t is equal to 4. That information all goes together. The when tips you off that this happens with those. So I'm going to plug those values in, do a little cleanup work, and find a value for k. Now that I have k, my job is to find the new value for r. I have a k, I have a v equals 2, and I have a t equals 8. Plug those in and get a new value for r. Okay. Our third kind of variation is called inverse variation. Sometimes you'll hear indirect variation, but most of the time the term used is inverse. In this case, what you're going to be writing is k over x, y equals k over x. Think about this way. Inverse variation means they go opposite directions. If x gets bigger, y gets smaller at the same rate. If x got smaller, that means y will get bigger. Okay. So here's our statement. Again, if P varies inversely as Q, there's a tip-off of what I'm looking at, inversely. So inversely tells me there's division going on. Same rule, first find K. P varies inversely as Q, so it's K over Q. And P equals 24 when Q equals 4. Those go together. And then, of course, I typed 6 here, so maybe I meant to say 6, and I just said the wrong thing, but that's okay. I can fix that. Now, if I multiply those to get K by itself, K is equal to 144. Now that I have a value for K, I can find the new value for P. Same equation. I know K is 144, and I know Q is 12, so I can solve and get P equal to 12. One more kind of variation that's going to come our way, and this one is called combined variation. You're going to be dealing with both direct and indirect or inverse variation in the same problem. And folks, for these, you have to really pay attention to the wording so that you set it up right. Okay, you have to really read it carefully. So it says, suppose P varies directly as R and inversely as T. Okay. P varies directly as R and inversely as T. Our job is still the same. First find our K. P is varying directly as R, so it's K times R, and then inversely as T. P's by itself varies directly, K times R, and then inversely divided by T. Now, if T is equal to 20, when P is equal to 4 and R is equal to 2, those values go together, plug those in. All right. To get K by itself, I need to multiply the 20 over to the 4 and then divide by the 2. So now I have a value of K is 40. Well, if K is 40, now I can find my new value for T using the same equation. P is negative 5, K is 40, R is 10 from here. Well, multiply the T over, negative 5T equals, cleaning that up, 400. Then a little division tells me that T equals negative 80. Okay. We've looked at several different kinds of variation, and so I've got a summary page here for you. When you see varies directly, direct variation, y varies directly as x, y will equal kx. Whatever is here goes by itself. Whatever's directly as goes over here with the k. When it's jointly, y varies jointly as x and z, you get y equals kxz. When y varies inversely as x, you have k over x, sorry, y equals k over x. And then for a combined variation, y varies directly as x and inversely as z, kx over z. Okay. Remember the game plan. First find k using information that goes together, and then using that k and your new information, find whichever variable they're asking for. As always, if you had questions along the way, hopefully you wrote those down. Bring them in to ask, and we will see you in class.